Welcome to your Chapter 15 Part 1 video. This is on freshwater. Alright, the very first part of this chapter is the central case, and it is about the Colorado River. This is a very long river that cuts through 7 states: Arizona, California, Colorado, Nevada, New Mexico, Utah, and Wyoming. I'm going to put up a map here in just a second. It is a massive water source for all of the states in this particular region of the U.S. It features 14 dams and reservoirs, lots of diversion projects, which we'll talk about in the second section, and it is withdrawn from a lot. And that is largely because it cuts through a lot of desert, and it starts in the Rocky Mountains, and its water is supplied mostly from snowmelt there from the Rocky Mountains. So what is this water used for? It's used for recreation. It's used for hydroelectric power. We will discuss how dams create electricity in a future unit. Water is used for watering plants and agriculture. It's used for drinking. It's used for watering people's lawns, including golf courses. And again, remember, this is in the middle of a desert. It's used to fill swimming pools. It's used for things like fountains at the Bellagio. And if you look at the bottom of this slide, you can see exactly where this river cuts through. And as we now know from the drought currently going on in California, the fact that this river is so huge is not enough. There are a variety of things that have gone into the reduction of the water's flow, and it is now diverted so much that this very end that's supposed to be dumping into the Gulf of California, oftentimes there's not enough water for it to hit the Gulf where it's supposed to come out. And in the second section of this chapter, we will discuss what all of the implications are with that. All right, what percentage of all water is saltwater? That would be 97.5%, which means that 2.5% of all water on this planet is freshwater. Of that freshwater, almost 80% of that 2.5% is locked away in ice caps and glaciers. At this point is always when my students like to talk about, hey, let's go get some ice and melt it, and then we'll have all the fresh water we need. We'll discuss in a later chapter in the climate change unit why it is that we need the ice to stay where it is. So of that 2.5%, about 21% of it is fresh water that we can get to. So that would be 20% of that 2.5% is groundwater, which is underneath the ground, and then the rest of it is rivers, stuff in the atmosphere, stuff in the soil, and then lakes. So basically, how much of the world's water is both fresh and easily accessible for human use? That would be less than 1% of the water that is on this planet. Alright, so one of the places that we can get water, as we saw with the Colorado River that I talked about earlier, is from rivers. So we need to understand how it flows from its headwaters, which is the beginning, to its mouth, which is the end. And we're going to be talking about sources for headwaters, why the river flows, what a tributary is, how a watershed is related to a river, what a floodplain is, and what a riparian zone is. There are a few other terms that go with rivers that we'll be discussing in the supplemental lecture that we'll have in class. So, streams are bodies of flowing water moving in one direction. They are driven by gravity, which is from a high area to a low area. The larger the difference is between the high area and the lower area, and the shorter the distance between the two, the faster the water moves. As an example, the Everglades has maybe a 6-inch tilt from its beginning to its end, so its water flow is really, really short. If you look at parts of rivers where there's whitewater rafting that occurs, the tilt is very steep, and so the water flow is to the point that it can actually end up killing you if you get caught up in it. That's whitewater rafting and all of the different gradations of difficulty there. Rivers are found everywhere. In terms of which way they flow, please remember that it's just going to depend where the headwaters are and the mouth of the river is, which is the end. There's no magical anything that says that they have to be pointed in a certain direction. It just all depends on how the topography ended up. The headwaters can be snowmelt, it can be springs, it can even be a huge lake. Little streams are called tributaries, and when they join into the major, they join into a larger river. So they're like little rivers that join a big river, and they then flow towards their mouth, which is usually some sort of other body of water like a lake or an ocean or a sea. Again, sometimes it's even just heavy rainfall that will help to drive a river, and this is more referring to the sources of water that come from places other than the headwaters. So every time it rains, you have surface water, which is stuff that doesn't sink into the soil. Remember the water cycle we already did, runs through land and then goes into streams. So I need for you to think of an area like this. You have all of these high points, and the river is at the lowest point. All of the areas where it can rain and water can run into a river is called a watershed. And as this previous slide details, it's also called a drainage basin. So it's the land area that delivers runoff, sediment, dissolved substances to a stream and large bodies of water. The implication is that anything that is between the edge of a watershed and the river, anything that's there can end up in the river, even if the river is miles and miles away, because water is a solvent. Water has, it runs with gravity, so its force and its ability to essentially grab things like pollution and sediment, take them down into the river, means that anything that is between the edge of the watershed and the river can end up impacting water quality. So as we start talking about pollution, that is something for you to remember. Let's see. Moving on to the next slide. Here's the downhill flow of water. This is a nice little picture for you. Floodplains are any areas where land can be submerged when the river rises to its highest point. Silt left behind after flooding makes the area very fertile, and that's where riparian zones occur. Give me a minute to get there and we'll discuss, but there are a few more details of the river that you really need to know. So be able to know the different characteristics of different parts of the river. Your cartoon guide already went over this. Headwaters are cold, they're clear, they have higher oxygen levels because they're moving really fast, and freshwater fish such as trout can be found in these areas. They've got to be strong also because the waters are moving so fast, usually at a headwater, that they have to have the ability to swim to stay basically in one place. Towards the middle part of the river, streams get wider, species diversity increases because you also have more sediment in there, so you have more plants, so then that means that you have more animals. Then as you get towards the mouth, river flow slows, it gets more murky, because again you have a buildup of all the sediment that it's picked up upstream. It decreases the amount of light that can penetrate through the water, so you have different varieties of fish. You usually find things like catfish in these particular areas. Diversity kind of goes, this is less diversity of flora, but the mouth of the river is known for its high biodiversity for other reasons that we're going to talk about when we start talking about estuaries. But do know that there are lower oxygen levels there because the water also gets warmer, it's shallower, and water holds less oxygen the warmer it gets. So again, catfish and carp that like to hide in muddy water and can handle the warmer, less oxygenated water live there. All right, riparian zones are very highly biodiverse areas that run along a stream, usually along the floodplains. They take advantage of all of that rich dirt, which I've been referring to as silt that's there. And just essentially know that riparian zones occur along the banks of a stream, and banks are basically the edges of a stream, and they are known for being very fertile and very productive. So what sometimes ends up happening is these areas are usually, not usually, but these areas are sometimes cut down and used for farming. All right, how does a river change its course? Here you can see time 1, time 2, times 3, and time 4. What's going on. As a river flows, the outer edge of the river, depending on which way it's flowing. So here, this is flowing, all of these rivers in this particular picture are flowing from left to right. It erodes on the far side of the bank, and then that means that soil is taken away from one side and deposited on the other side. So it erodes from the outer part of a loop of the stream, and then it deposits on the inner part of the loop of a stream. And this changes the course of a river over time. This is called meandering. This is a natural process. In a little bit, we're going to discuss why it is. Well, you know what? I'll talk about it now. Humans don't like this because we use streams for, among other things, transportation. And if the stream gets more and more bendy, that means that it takes longer and longer for you to get your goods anywhere. So oftentimes we will, as humans, stop this from happening. And why is this a problem? Because nature depends upon these deposits of soil on the inner loops of the stream, and so you're kind of messing with the natural order of things. Now, as the meandering continues and these loops, which are called oxbows, become more and more pronounced, eventually the loops will touch, or you could say that they kiss, and where they kiss, they basically pinch off from the rest of the river, forming an oxbow lake. Now here's where you can start pulling things in from previous units. You should start thinking things like, allopatric speciation can occur here because a physical barrier has occurred between the fish that are in other organisms that are caught up in this oxbow lake and the rest of the river. So that means at some point these oxbow lakes become areas where unique species of organisms occur because of genetic drift. Here in this picture on the right, you can see where a lot of oxbow lakes have formed, and then some have essentially dried up due to the meandering of the river. All right, so your next question says, differentiate between the following types of freshwater wetlands. A freshwater wetland is anywhere where you have ground that is partially submerged under the water, and it can either be there year-round or it can be seasonal when you have rains or flooding. Now, the things that these guys do is they act as filtration systems for water. So if water comes in polluted, when it ends up in groundwaters and aquifers, which we're going to talk about in a second, they're cleaner. Reduces flooding and erosion because they kind of can absorb water levels because they're kind of used to being underwater. They keep areas that are not used to flooding from being flooded. They replenish streams during dry season, so if water goes into a wetland, it can then go back out of the wetland into the stream. They are recharge points for aquifers oftentimes, and they help to maintain diversity. These freshwater wetlands are very famous for having a lot of different stuff going on. Because it's very shallow, not only do you have aquatic stuff that lives in there, you have other things like birds and other sorts of mammals that will live in and around the area, reptiles and all that other good stuff. So, 3 types of freshwater wetlands you need to know about before we get to the supplemental material. That's marshes, swamps, and bogs. Marshes, you have grasses and reeds with few to no trees. Swamps are essentially marshes with lots of trees in them. We see swamps and marshes down here in Florida. The Everglades is essentially a marsh. Swamps are stuff with cypress trees in it usually. Swamps can also be formed by beavers and their dams. And then you have things that are called bogs, which are ponds that are covered with floating mats of vegetation. So I've got a couple of pictures for you. Left-hand picture is a picture of a swamp. Upper right is a marsh. Lower right is a bog. So when you see these things, you should think water doesn't flow very much. So you got to think the animals that live in there in the water can tolerate low levels of oxygen, but they're also very highly diverse, and you usually find a lot of really unique critters living in them. All right, list 5 ecosystem services wetlands provide. I kind of went over that. They're a habitat area. They slow runoff. They reduce flooding. They help to recharge aquifers, and they filter pollutants out of water. So here is a picture for you of what wetlands do. If you are more of a picture person, pause here and take a look at this and kind of take it all in. All right, next question is, identify the following life zones of a freshwater pond. The littoral zone. The littoral zone, if you think about those two T's as being like a growing plant, the littoral zone is the edge of a pond or a lake where rooted plants occur, even the submerged guys. The second those rooted plants stop, that then becomes the limnetic zone. The limnetic zone, as we're going to find in terms of water, it goes both across and down. It's more associated with the across part, which is the open water part of a lake or a pond. When you go down, that's also called the limnetic zone, as you can see here in this picture, but it's also called the photic zone. That's where it's lit. The part of a lake that is water, where no light occurs, which means no photosynthesis occurs there, is called the profundal zone. All along the muddy bottom of a lake or pond, where you have all kinds of things, filter feeders like clams and other crustaceans, that is called the benthic zone. Be able to identify what you can find in these different areas. Stuff that lives in the profundal zone are a lot of things that feast on detritus, which is essentially water trash that floats down because there's no plants that live down there. The limnetic zone is where you have a lot more predators. If you are a prey fish, you're probably going to live in the plant area, so you have a place to hide, or even in the profundal zone where stuff can't see you. All right, differences between an oligotrophic lake and a eutrophic lake. Oligotrophic, not a lot of phosphorus, phosphates and nitrates in there, so not a lot of nutrients, not a lot of plants, low biodiversity overall, high in oxygen, usually crystal clear and very deep. Eutrophic is opposite, usually shallower, more murky, which means more turbidity, which is more suspended solids in there, high biodiversity, high nutrients, lower levels of lower level of oxygen. Most lakes fall between these two extremes. You can have, you remember primary and secondary succession? You can have a succession between an oligotrophic lake to a eutrophic lake to a lake that eventually fills in and disappears. So same lake, same place, you can transition from one to the other over time. Here's a nice picture of a difference between a oligotrophic and a eutrophic lake. Remember, this is your video. Stop and take a look at these pictures if you need to. And then also here, oligotrophic versus eutrophic. I apologize for this being a little blurry, but you do what you can with what you got. All right, this next section, identify and describe groundwater zones, and this is all talking about aquifers. So, got several slides on this. This is super important because aquifers, besides lakes and rivers, are our primary source of water as humans. So, imagine, if you will, a cross section, as you can see here. I'm going to start with the zones first. Okay, an aquifer is an area. It is not a bubble of water underground. It is a porous area. It's either a rock with pores in it, like limestone, like we have here in Florida, or it's gravel or anything like that, where in between the pockets or the pores, in those empty spaces, water collects. So, in an aquifer, you have a couple of zones. You have the zone of saturation, where it is completely full of water and you cannot put a single drop more. And then you have the zone of aeration, which is free pockets or pores where water can still fit. The imaginary line between the zone of aeration and the zone of saturation is the water table. Different areas have characteristically different depths to get to the water table. Places like New Orleans, the water table is essentially right at the surface of the ground. That's why you can't bury people underwater, or coffins will just come popping, or underwater, under the soil, or coffins will just come popping out of the ground. That's why they have lots of mausoleums, which is above ground areas where they park their dead. Other places you have to dig for upwards of a mile to get to the water table. Also realize that the water table is going to vary depending on how much the water is used. If you have areas where humans are drawing on aquifers faster than they can be refilled, which is called recharged, then the water table is going to drop and drop and drop. And we're seeing this in California, where they're having to dig wells miles deep in order to hit that ground table that used to be a lot more shallow under the ground. All right, so I've talked about kind of recharge areas. I'm going to talk about that in a second. I've talked about zone of aeration, zone of saturation, and water table. So you can think about aquifers as being two different sorts. You have unconfined aquifers, which you can see here in this picture. Unconfined aquifers means when it rains or water percolates down into the soil, boom, that goes into the aquifer. You're not a problem. Confined aquifers are aquifers that are that are kind of sandwiched in between a layer of rock. So, and then they usually can only be recharged in one particular area. I'm going to talk about the implications of that in just a second. Now, since I'm on the slide, how do we get to water? Well, or aquifers, excuse me. Well, we dig wells. And wells are of two types. You can either have an artesian well, which is actually can be natural. That's what a spring is. The water just bubbles out on its own. Or you can have a man-made artesian well, which is, if you think about an aquifer as being like a Capri Sun pouch, and you hold it in your hand and you kind of squeeze it a little bit, and then you take a straw and you punch it in there, it just comes spurting out on its own. So artesian basically means you have to do nothing to get the water out. Now, it should make sense to you that if you're digging a well, at some point you're going to have to start sucking on that straw to get the liquid out. And if water is not flowing in as fast as you're pumping it out. So, another question to ask yourself is, what do you do when the Capri Sun pouch is empty? It's empty and you run out of water, which again we have seen in California, and I'm going to address that drought situation, I believe, in the second part of this chapter. All right. Okay, we've already talked about this. The height of the water table changes seasonally, so wells are drilled to extend below the water table. Some of you may actually drink from well water. Here in Lee County, we have well water. If water tables fall below the bottom of the well during a drought, the well will dry up. And to continue supplying water, the well must be drilled deeper. Some of you may have experienced this. And here's another picture of what an aquifer looks like, and water tables, and how we get water out of an aquifer, and how that all works. I know this is a little bit beyond what your questions are asking, but these are the kind of things that you can be expected to comment on the national exam. Okay, again, a recharge zone, an area in which water travels downward to become part of an aquifer. Impermeable areas like rock, like granite and basalt, don't let water flow into an aquifer. Please realize any pollution in the recharge zone can also enter the aquifer. So things like what happens when a recharge zone is capped by human settlement. Aquifer goes dry, it doesn't have a way of filling up. The size of an aquifer's recharge zone is affected by the permeability of the surface above the aquifer. Structures such as buildings and parking lots can act as impermeable layers and reduce the amount of water entering an aquifer. This is a huge deal here in the state of Florida, and it's why you probably want to know where the recharge zones are for the aquifers that you drink from. Because if you have a developer going, I'll pay you $11 cajillion to be able to build a new mall and a parking lot here, and you go, great, give me the money, and then you go, oh, wait, that's the only place our aquifer recharges? Yeah, no. Also, hey, can I build a landfill in this area? Yeah, I don't want the pollution from the landfill in my water. Thank you very much. Because do realize that aquifers can take tens of thousands of years to refill. So here again, you can see different sorts of aquifers. This is a better picture here of an unconfined. In a confined aquifer, you can see the unconfined aquifer gets filled in any number of areas, and a confined aquifer has a tiny little recharge area. This also shows you ways that water ends up getting to and from different places. Let's see, another question. How does an aquifer recharge? Rain and other surface water percolating downwards. How does it empty? Natural springs and human removal through wells. I've already talked about what an artesian well is. That's one of your vocab words. How does groundwater move? It moves from areas of high pressure to areas of low pressure. How fast does it move? Very slowly, an average of about 3 feet per day. One more commentary about the difference between a confined and an unconfined aquifer. Confined aquifers are under high pressure because, if you look at them, come on and go back. They're under pressure from the rock that's here. So you can imagine that if you poke a hole in it, confined aquifers are really, really good places to get water out of, because you don't have to do a lot once you poke the hole to make the water come out. Of course, the downside is they only recharge in a certain area. Unconfined aquifers, easier to fill up, but you actually have to work to get the water out of them, because it's under a lower pressure, so you've actually got to pump that stuff out there. All right, what is the world's largest aquifer? One of my favorite words to say, the Ogallala Aquifer. Where is it located? It's the Midwest United States. It touches Wyoming, Nebraska, Colorado, Kansas, Oklahoma, New Mexico, and Texas. I would imagine on a national exam that you may be asked to name one of those states. I would go with Nebraska, because if you look, the majority of the aquifer is under Nebraska. Surprising absolutely no one. Lots of agriculture going on there, because hello, you've got this giant reservoir of water to draw from. Now, of course, we are drawing on this thing faster than it can refill. Then at some point it's going to go dry. Okay, your last question. Be able to comment on the unequal distribution of water, where fresh water is readily found and where it is in scarce supply. Deserts have greater shortages than areas over aquifers or in areas where it rains a lot, like the tropical rainforest. But do realize that water scarcity is not just based on physical scarcity, it is also based on economic scarcity. In a lot of places in the globe, water supplies are incredibly fouled. In other words, they are full of pollution, and these areas do not have water treatment plants. There are also places here where water has been privatized. In other words, people own the land where you find water, and they're not about to give it to poor people, because that's not how you make money. So do realize again that there's an economic component to water scarcity. All right, and thus ends Chapter 15, Part 1.